Okay, so before we get started, I'm going to give you a couple hints to help you with the problems as you go through them. Number 6 says, which of the following transformations results in a figure congruent to the original? Congruent is a key word here. Congruent means same shape. So write this down on your paper, same size. Because remember, this is also a study tool as well. Same shape, same size. So when you go through these answer choices, you're looking for the ones that just stay the same shape, same size. This is also a select all question, so there's going to be more than one correct answer. You can change the location without changing the shape or the size. So if you change its location, if you flip it, if you turn it, it's still going to be the same shape, same size. So it's a select all. Then number 7, it says, what are the steps can be used to prove that angle B is congruent to angle F? So I want you to prove that this angle is congruent to this one, given that line M is parallel to N. So we have parallel lines and a transversal. Just looking at those two angles, we can see that they're corresponding angles. However, the answer key did it a little bit different than that. We're going to set it up as a proof, statements, and reasons. So setting up the proof. On the EOC, you're not going to have to set up a proof from scratch. Honestly, they would have most of the blanks filled in. You just have to fill in like 1 or 2 of the blanks. So keep that in mind. You wouldn't have to do this from scratch. So the first thing that you always start out with in a proof is the given. And it tells us given M is parallel to N. So that would be our given. According to the answer key, they did this in 4 steps, with the last step being that angle B is congruent to angle F, which is what you're trying to prove here. I'm going to leave it like this. You can maybe fill in what you might think. Remember, it's not just about getting the correct answer. When you try it on your own, it's practicing like pulling the information that you remember out of your brain so that way you can access it easily. Number 8. Highlands Park is located between 2 parallel streets. So these are the parallel streets right here, Walker Street and James Avenue, parallel lines. That means that these lines are transversals and they follow all the rules of parallel lines with a transversal. We also are shown that this is a 60-degree angle, this is a 36-degree angle, and it asks us for angle ACB. When identifying that angle, we need to look at the letters in order, A, C, B, and that middle letter is what we're trying to find. So that's what you're going to try to figure out. So you're going to use the rules for parallel lines with a transversal to maybe figure out this angle, and then these 3 angles add up to 180, so you can use that to figure out the missing angle. Then number 9. It's another proof problem. It says given xz is a perpendicular bisector of wy, so xz perpendicular bisector, that means that this line is perpendicular to this line, and it's also a bisector. Bisector means that it breaks it exactly in half, so this would be the same measure as this. Prove that this triangle is isosceles. So to prove that this triangle is isosceles, you'd have to prove that this side is the same length as this one, and that's where they're headed with this. Determine 3 more statements and reasons to complete the proof. So they give us 1, 2, 3, 4. There's no room here because I had to kind of condense this, but we're going to do 5, 6, and 7 because it needs 3 more statements and reasons. So just set this up over here. And you can try to look at this and fill these in on your own, and then we'll go over it and fill them in as well. And number 10. Number 10, it shows a quadrilateral. It says, based on the figure shown, which of the following statements will guarantee, that's important, guarantee that this is a parallelogram? Before we look at the answer choices, I'm just going over some of the properties of parallelograms. With parallelograms, opposite sides are the same measure. So this would be the same length as this, and this would be the same length as this side. And then also opposite angles are congruent, so this would be the same measure here, and then this angle would be the same measure as this one. Also, parallelograms have opposite sides parallel, so this being parallel to this would mean that you have a transversal, and it also follows the rules of parallel lines with a transversal. So like consecutive interior angles would be supplementary, and that is important as well. Consecutive interior angles are supplementary, meaning that these two angles would add to 180. And then this is just one correct answer, so just choose the best answer choice there. Okay, so now I'm going to set a timer for 5 minutes, see what you can fill in or figure out on your own, and then after that I'll go over and we can compare answers. Okay, if you're doing this online, just set a timer as well. I'm going to pause the video now, so pause this video, try it on your own, and then come back for the instruction. Okay, video resumed. Okay. So now that you've had a chance to look it over, we're going to go through each one in more detail. So, which of the following transformations results in a figure congruent to the original? If you look through each of those, a rotation of 270 degrees followed by a translation. So you're rotating the shape and then sliding it. You're not changing its shape or size. So that is a correct answer. A reflection over the y-axis, you're reflecting it, but again, not changing the shape or size, so that is also a correct answer. This one says reflection over the x-axis followed by a dilation. Now, a dilation is when when the figure grows or shrinks, so it would be like a triangle growing. That is not the same size, so therefore this does not keep its same shape and size. It is not congruent to the original. Then for the fourth answer, translation of 4 units to the left followed by a reflection. Translation is a slide, just new location, or reflection, again, flipping it, but still keeping its shape and size. So that is correct as well. Okay, and the next one. I told you that you could prove that those are congruent by corresponding angles postulate, but the way they did it in the answer key is the way I'm going to show you here. So they said that, well, angle B is a vertical angle with angle D, so those two are vertical angles. So angle B is congruent to angle D, vertical angle theorem. Then they said, okay, D is congruent to F because of alternate interior angles theorem. So angle D is congruent to angle F, alternate interior angles theorem, abbreviated. Okay, now what? Well, if B is equal to D and D is equal to F, then B must also be equal to F. Do you remember what that's called? It's called the transitive property. I know it's been a while. Transitive property. The example I used when I taught that was if Caitlin's the same height as Leah and Leah's the same height as Giselle, then Caitlin must be the same height as Giselle. That's the concept. So it also applies in geometry as well. Okay, and number 8, I showed you that the question says that there you have the parallel lines. That would make this a transversal. Alternate interior angles are congruent. So if this is 36 degrees, this is 36 degrees. And then because these 3 angles form a straight line, we can do 180 minus 60 degrees minus 36 to get this angle here. It comes out to 84 degrees. And next, all right, still writing. Number 9. Okay, I already read the problem. It said that XZ is a perpendicular bisector to this segment. So that means this is a 90-degree angle, and that means that these two sides are congruent. We need to prove that this is isosceles, and we can do that by proving that these two sides are the same measure. And they already started the proof for us. So they started out with the given, which we stated, and then it says that WX is congruent to YX. So they're saying this is the same distance here because of definition of bisector. They're saying angle 1 is equal to angle 2, which is 90 degrees, because it's perpendicular bisector by definition. And then XZ is congruent to XZ. That was reflexive property when a line is just equal to itself. Now we're going to prove that these two triangles are congruent. There's two triangles there. There is a triangle right here, and a triangle right here in the picture. And we can prove that those two triangles are congruent by side angle side congruence. So we can say that triangle WXZ is congruent to triangle YXZ because of side angle side. Now what? Well, if you have two congruent triangles, then all their parts are congruent. So that means that this side would be the same length as this side. So now we can say that WZ is congruent to YZ because corresponding parts are congruent. And the acronym for this is Cpctc. And just kind of making ourselves a note. Cpctc, remember this is used as a study guide, so write down Cpctc stands for corresponding parts of congruent triangles are congruent. So now that we know that this is equal to this, we can say that triangle WYZ is isosceles. And the reason is definition of isosceles triangle, and I'm abbreviating by a lot. And those not listening to the instruction probably thinks that this is like another language. Okay. And the last one. I already talked about the properties of parallelograms, so now we're just going to go through the answer choices and see which one guarantees that this is a parallelogram. So the first one says that all the angles add up to 360. That is accurate, however, it doesn't guarantee it's a parallelogram. That would guarantee it's a quadrilateral, but not specifically a parallelogram. So nope to that one. The next one, remember they give us that this angle is 40 degrees. They're also saying that DCB is 40 degrees. That would mean one pair of opposite angles are congruent. And then they're telling us that measure of ABC, which is this angle, is 140. If this is 40 degrees and this is 140, that means your consecutive angles are supplementary. So therefore, this would prove it's a parallelogram. So this is probably the correct answer. Then here, just two angles being supplementary doesn't prove it's a parallelogram. It could also be a trapezoid or something like that. And then measure of DCB being 40 degrees, one pair of opposite angles doesn't prove it's a parallelogram as well. So this is the correct answer. So opposite angles are equal and consecutive interior angles are supplementary. Okay, in a second, I'm going to have you turn this in. If you're doing this online, you need to upload it to Schoology, to the assignment. Just take a picture and I'll add the grade to your grade book, or to the grade book. Also, note that you need to have your notes printed by next week. I uploaded them to Schoology already, so you can print them from Schoology. If you don't have a printer, you need to print them from the Media Center today. If for whatever reason you're quarantined or more of us get quarantined, then you'll have your notes ready for next week and ready to go for online instruction if needed. So, have a good weekend, quarantined students. See ya. No, see you later. Bye.